Welcome everyone to this live podcast on Twitch, where you can find the news from the research industry that how our researchers keep on researching on various topics and domain to keep our lifestyle better, of course. And this article posted on our website named postscientist.com. So if you are willing to check it out, please check it out. Otherwise, listening to this podcast will be enough for you guys, as it acts like an archive on the daily basis, providing providing you the information from the research industry. So, without wasting any further time, let's get started with the first topic of the day. Artificial intelligence and molecule machine join forces to generalize automated chemistry. Okay, let's see. Artificial intelligence building block chemistry and a molecule making machine teamed up to find the best general reaction condition for synthesizing chemicals important to biomedical and material research, a finding that could speed innovation and drug discovery as well as make complex chemistry automated and accessible. With the machine generator optimized condition, researcher at the University of Illinois Urbana, Champaign, and collaborators Poland and Canada doubled the average yield of a special, hard to optimize type of reaction linking carbon atoms together in pharmaceutically important molecules. The researchers say their system provides a platform that also could be used to find general conditions for other classes of reaction and solution for similarly complex problems. They reported their findings in the journal Science. Generality is critical for automation and thus making molecular innovation accessible even to non-chemists, said study co-leader Dr. Martin D. Burke, an Illinois professor of chemistry and of the Carl Day Illinois College of Medicine, as well as medical doctor. The challenge is the hashtag of possible reaction condition is astronomically and the needle is hidden somewhere inside. By leveraging the power of artificial intelligence building block chemistry to create a feedback loop, we were able to shrink the haystack and we found the needle. Automated synthesis machine for proteins and nucleic acids such as DNA have revolutionized research and chemical manufacture in those fields, but many chemical of importance for pharmaceutical, clinical, and manufacturing and material applications are small molecules with complex structure, and the researcher says. Burke Group has pioneered the development of simple chemical building block for small molecules. His lab also developed an automated molecule machine making machine that snap together the building block to create a wide range of possible structures. However, general reaction conditions to make the automated process broadly applicable have remained elusive. Traditionally, chemists customize the reaction condition for each product they are trying to make, Burke said. The problem is that this is slow and very specialist dependent process and very hard to automate because the machine would have to optimize every time. What we really want are conditions that work almost every time. No matter what two things you are trying to snap together, an automated approach with generalized condition could help standardize how some products are made, addressing the problem of reproductibility, and said Illinois postdoctoral research Vandana Rathod, a co-first author of the study. Burke Group, Burske Group teamed up with a group led by Bartsev A. Grosbowski at the Polish Academy of Sciences Institute for Organic Chemistry, as well as the group of Alan Espiro Guzik at the University of Toronto, both leaders in using artificial intelligence and machine learning to improve chemical synthesis. The team integrated AI with the molecule machine to provide real time feedback to the machine learning system. To distinguish good and bad, you need to know something about the bad, but people only publish the successes. Grabowski said published studies reflect conditions that are popular or convenient rather than the best, so a systematic approach that included diverse data and negative results was necessary, he said. First, the team ran the entire matrix of possible combination using the building block chemistry through an algorithm to group together similar reactions. Then the AI set instructions inputted to a machine in the molecule maker lab located in the Beckman Institute for Advanced Science and Technology at Illinois to produce representative reaction from each cluster. The information from those reactions fed back into the model. The AI trained learned from the data and ordered more experiment from the molecule machine. We were looking to see two things: an increase in yield and a decrease in uncertainty for a broad spectrum of reaction, said Grabowski, who now is at Ulsan Institute of Science and Technology in South Korea. This loop continued without us having to intervene until the problem was solved. Figuring out the generalized condition for protein synthesis machine took 30 years. They took us 2 months. The process identified a condition that doubled the average yield of a challenging class of a reaction called heteroadyl Suzuki-Miyamoto coupling, crucial for many biological and materials relevant compounds. There are all kinds of building block combinations that we didn't even study in our AI training, but because the AI had explored such a diverse space, it found good result even in those initial unexplored areas, said Illinois graduate student Nicholas H. Anglo, co-first author of the study. Of course, man, we don't know, and it's been very diverse topic which we need to be explored. The machine learning process described in the paper also could be applied to other broad areas of chemistry to find the best reaction condition for other types of small molecule or even larger organic polymers, the researcher says. There are so many different material classes that we want to know, target and discover for different functional properties. The extension possibility of this approach to other similar reaction chemistry, other types of carbon-carbon links is exciting, said study co-author Charles M. Schroders, Illinois professor of material science and engineering and chemical and biomolecular engineering at a Beckman Institute affiliate. So these are the studies given by our scientists, researchers on this topic using AI and machine learning projects to promote the chemical advances in the automated uh, in the forces. So yep. Moving on towards next topic. Study reveals sharp rise in stroke cases among young adults in Oxfordshire. New research has shown a sharp increase in the incidence of stroke in young adults in a study of more than 94,000 people in Oxfordshire. Stroke is a major health problem that can have devastating consequences. It happens when the blood supply to the brain is cut off, causing the death of brain cells and dysfunction in one or more parts of the brain. The restricted blood supply can be the result of an artery supplying blood to brain becoming blocked, a blood vessel rupturing causing a bleed inside the brain, or a brief reduction in the blood supply to the brain. Findings from this new study, which analyzed the rate of new stroke cases in Oxfordshire over the last 20 years, reflect emerging evidence that young stroke is a growing problem in high-income countries. The traditional view is that vascular risk factors such as high blood pressure, diabetes, and obesity play a minor role in young stroke, but recent studies have begun to contradict this view. Thanks to a research fellowship from the foundation of Dr. Lindsay Lee from the University of Oxford is investigating the role of these treatable risk factors in young stroke. Dr. Lee researchers focus on multiple types of strokes such as ischemic stroke caused by a blockage of arteries, mini stroke, transient ischemic attacks, and bleeding in the brain, intercerebral hemorrhage, and subarachnoid hemorrhage. This new study, led by researchers from the Nuffield Department of Clinical Neuroscience at the University of Oxford, is published in a recent issue of the journal JAMA. The researcher explored whether stroke incidence in younger and older people changed from 2002 to 2018 drawing a data from the Oxford Vascular Study, which comprises 94,567 people registered with GP practices across Oxfordshire. Incidence refer to the number of people who develop a specific disease or health related event. In this case, stroke during a particular time period. Incident refer to the number of people who develop a specific disease or a health related event, in this case a stroke, during a particular time period. The researcher also took into account other factors such as lifestyle changes in diagnostic practices, control of traditional vascular risk factor, and sex specific cause of stroke. They found that between 2002 to 2010 and 2010 to 2018, there was a 67% increase in the stroke incidence among younger adults under 55 years and a 15% decrease among older adults 55 years or older. A similar divergence in incidence was not found for other vascular events such as heart attacks among young people who had a stroke. There was a significant increase in the proportion who were in the more skilled occupations, particularly for potential or managerial jobs. This could suggest a role for work-related stress, low physical activity, and long working hours, each of which were more strongly associated with risk of stroke than heart attack. The prevalence of traditional vascular risk factor in young people with stroke was also high, emphasizing the importance of identifying and managing these risk factors. A linked paper in the current October issue of JAMA Neurology by the same author showed similar divergent trends across other high income countries in the 21st century, with a fall in incidence at older ages not being seen at younger ages. Medical Research Foundation fellow Dr. Lindsay Lee from the University of Oxford said our study shows a worrying rise in young stroke cases across Oxfordshire, reflecting a similar picture across other high income countries. Establishing the importance of non risk factor young stroke will help to raise a general awareness of the need for better control. We also need better ways of identifying young people at high risk of stroke, as current risk models are based on predictors of stroke in older people. Dr. Angela Hind, chief executive of the Medical Research Foundation, said, historically, we have thought of stroke as only affecting older adults, but studies like this suggest a growing problem in young adults. Stroke in young adults can have a huge impact, often occurring when they are starting a family or already have young children to look after and have yet to reach the peak of their careers. The economic, social, and personal consequences can be devastating. More research needs to be done to increase understanding of the causes of young stroke and the best ways of preventing it. This is why we are supporting researchers like Dr. Lee, who are pushing forward the boundaries of knowledge surrounding young stroke. So these are the study, these are the findings given by our researcher on the study reveal of the stroke life. I mean, it's an important topic to raise upon, and yes, if you are into news, many people die, have an heart attack, stroke in the soul itself. So, I mean, it's being an issue nowadays or all around the world, so it's a necessary topic to raise this issue on this platform. Thanks for our research to research this kind of topic and study on this type of topics and raising this topic, of course. So yes, is it necessary to raise this topic because young people is only the future of any country, whether it's a developing country or is a developed country, because those are the people who are the brains of the country, who are the muscular people of the country. Otherwise, I mean, having older people in their country just rely on the experience is not going to be done anything in any country itself. So yep. Okay, moving on towards next topic. Topological near field generated by topological structures. Okay. Metamaterial Meta-optics offered a broad dimension to explore exotic functionalities in physics and optics. In a new report now published in Science Advances, Ji Peng and a team of scientists in physics and interdisciplinary study at the City University of Hong Kong, China, discovered how the topology of structure can dictate the properties of optical field to offer a new dimension of exploration in optic functionality. The non-trivial topology of metal structure facilitated the birth of polarization, singularity, and the outcome of the study bridged singular optic, topological photonic, and non-Hermitian physics for application across chiral sensing, quantum optics, and photonics. A universal connection between topology and optical structures. The concept of topology can provide a new perspective for physicists to explore unconventional properties of one-way edge states in topological insulator and their counterparts. The distribution of polarization ellipses can form topological effects known as polarization singularities, which emerge during applications such as light focusing, scattering, and interference in nanostructure, including matter surface and photonic crystals. The geometry of the optical structure can still decide the local region of optical modes to give rise to new optical devices including nano antenna, metamaterial, and meta surfaces. In this work, Pang et al. Established a universal exact connection between topology and optical structure to reveal how the origin and topological evolution of magnetic polarization in the near field were bound by the topology and the symmetry of the structures. Polarization singularity protected by surface topology of structure. The team conducted full wave numerical simulation of the system by using a finite element package via COMSOL multiphysics. During the experiment, they consider a metal sphere under the incidence of a plane propagating in the z direction with a magnetic field linearly polarized in the y direction. They then determine polarization singularity emerging in the total magnetic field. Pang and the team further sought to understand the underlying basis of the morphologies of PSLs, which they found in topological properties associated with the geometry of metal spheres. For example, the excitation of the incidence electromagnetic field induced currents in the metal structure, mainly localized in a thin surface layer of the structures. The study outcome established a direct link between the topology of optical structure and the topological properties of optical near fields, applicable for arbitrary metal structure with smooth geometric surface and small skin depth. The emergence of polarization singularity was further protected by the topology of the structure. Therefore, their properties were robust against continued variation of the geometric structures. Topology and mirror symmetry was topology and generalized rotational symmetry. The scientists noted how the polarization singularity further evolved as they extended away from the surface of the structure to merge, bifurcate, and transition in the three-dimensional space. The team examined topological transition of polarization singularities and further examined the properties of polarization singularity by discussing the combined effects of mirror symmetry and topology. The study outcome emphasized the significance of spatial symmetry to engender the topological complex polarization configuration that could not stably exist in non-symmetry. The researcher noted how the higher order polarization singularity and polarization singularity lines were typically unstable without symmetry protection to transform into the lowest order under perturbation. Outlook. In this way, G. Pang and colleagues showed a direct relationship between the topology of metal structures and magnetic polarization singularity lines in the near field. The study highlighted exotic topological properties of optical polarization field that are irrelevant to the specific material or geometry of optical structure. The outcomes are connected to polarization singularities as well as topological symmetry of structure and non-Hermitian physics. The study opens new opportunity for fundamental exploration in discerning chiral counterparts for sensing application chiral quantum optics and topological photonics. The team envisioned extending these outcomes to classical wave systems including sound waves and water surface waves. Water surface waves. So these are the studies, these are the findings given by our scientists on the researchers. Yep. Moving on towards next topic. Neanderthal extinction may have been caused by sex, not fighting. Interesting topic, right? Let's see. A new paper proposed that Homo sapiens may have been responsible for the extinction of Neanderthals not by violence but through sex instead. Making love not war might have been responsible for putting the Neanderthals on a path to extinction. Okay, making love not war might have the responsible for putting the Neanderthal on a path of extinction. Okay. While about 2% of the genome of all living people from outside Africa is derived from Neanderthals, there is a very little evidence that this process went the other way. A new paper published in the journal Paleoanthropology raises the prospect that interbreeding with our ancestors would have reduced the number of Neanderthal breeding with each other, leading to their eventual extinction. Through only 32 Neanderthal genomes have been sequenced to date, leaving it possible that the lack of Homo sapien DNA in their genome is actually a quirk of sampling. The author hope advances in DNA sequencing technology will be able to resolve this hypothesis by making more genomes available. Professor Chris Stringer, a museum research leader in human evolution, authored the new paper alongside colleague Dr. Leslie Creative. Chris says our knowledge of the interaction between Homo sapien and Neanderthal has got more complex in the last few years, but it's still rare to see scientific discussion of how the interbreeding between the groups actually happened. We propose that this behavior could have led to the Neanderthal extinction if they were regularly breeding with Homo sapiens, which could have eroded their population until they disappeared. The first encounter of Neanderthal and Homo sapiens. The Neanderthal and Homo sapiens diverged from each other around 600,000 years ago and evolved in very different areas of the world. Fossils of Neanderthal have been found across Europe and Asia, reaching us as far as southern Siberia. It is believed they spent at least 4,000 years evolving in this environment, adapting to a predominantly cooler climate than is found today. Meanwhile, the ancestor of our own species evolved in Africa. It is currently uncertain whether Homo sapiens are the direct descendants of one group of ancient African Homians or are the result of mixing between different groups spread across the continent. From genetic data, it looks like the two species first encountered each other when Homo sapiens began making occasional forays out of Africa about 250,000 years ago. Without knowing exactly what Neanderthal looked or behaved like, we can only speculate what Homo sapiens would have thought of their relative Chris's. The language difference would probably have been greater than we could imagine given the time depth of the separation and would have been much larger than those between any modern languages. The language barrier may have been reinforced by the individual attributes of both species with comparison of Neanderthal and Homo sapiens, suggesting that their brains and vocal apparatus of the species were different. The genome of Neanderthals also showed that almost 600 genes were expressed differently between our species and their, particularly those associated with the face and voice. Another prominent difference would have been the forehead, with Neanderthal processing a prominent brow ridge that could have been used for social communication. However, the signals these ridges were trying to convey could well have been lost on our ancestors. Some studies suggest that reduced brow ridges allowed Homo sapiens to turn instead to the eyebrows to convey a range of subtler temporary signals. In any event, this encounter eventually led to breeding between both species, but exactly how this occurred is also shrouded in mystery. Neanderthal and Homo sapien interbreeding. We know that our species interbred with Neanderthals since our relative first genomes were sequenced. However, the Neanderthal genes we have in us today are not the result of the early sporadic interaction Homo sapien had when they first left Africa. Instead, they come from the much larger migration that modern humans undertook around 60,000 years ago. Interbreeding at this time may have been a result of mutual courtship or could have been less friendly encounters between separate groups of our closest living relatives. Chimpanzees show evidence of both behaviors. Whether or not breeding was successful appeared to depend on the exact pair that was breeding. So far, there is no evidence of Homo sapien genetics in late Neanderthal genomes dating to between 40 to 60,000 years ago. It is possible this is due to a process of hybridization itself, as some species are only capable of producing offspring in certain direction. For instance, pollen from the Capsula rubella plant can successfully fertilize Capsula grandiflora seeds, but not the other way around. The lack of mitochondrial DNA, which is inherited through female from Neanderthal in living humans, has been suggested as evident that only male Neanderthal and female Homo sapien could mate. But there is also some evidence that male hybrids may have been less fertile than females, with fewer Neanderthal breeding with each other in group sizes already small and scattered due to the environment. Hybridization outside of Neanderthal family groups could uh, have helped push the species into decline. At the moment, however, there isn't enough evidence to decide either way. We don't know if the apparent one way gene flow is because it simply wasn't happening, that the breeding was taking place but was successful, or if the nether genomes we have are unrepresentative crises. As more nether genomes are sequenced, we should be able to see whether any nuclear DNA from Homo sapien was passed on to Neanderthal and demonstrate whether or not this idea is accurate. Further research could also investigate similar questions relating to another hominian species known as Denisovians, giving us a greater idea of how our species interacted with its closest relatives. Moving on towards next topic, new potential hazardous asteroid discovered. An international team of astronomers on Monday announced the discovery of a large asteroid whose orbit crosses that of Earth, creating a small chance far in the future of a catastrophic collision. The 1.5 km 0.9 mile wide asteroid named 2022 AP7 was discovered in area notoriously difficult to spot object due to the glare from the sun. It was found along with two other near Earth asteroids using a high tech instrument on the Victor M. Belenko telescope in Chile that was originally developed to study dark matter. 2022 AP7 crosses Earth orbit, which makes it potentially hazardous asteroid, but it currently doesn't know now or any time in the future have a trajectory that will have it collide with the Earth, said lead author of the findings, astronomer Scott Shepard of the Carnegie Institution for Science. The potential threat comes from the fact that, like any orbiting object, its trajectory will be slowly modified due to myriad gravitational forces, notably by planets. Forecasts are therefore difficult on the very long term. The newly discovered asteroid is the largest object that is potentially hazardous to Earth to be discovered in the last 8 years, said Nord Lab, a US funded research group that operates multiple observatories. 2022 AP7 takes 5 years to circle the Sun under its current orbit, which at its closest point to Earth remains several million kilometers away. The risk is therefore very small, but in case of a collision, an asteroid of that size would have a devastating impact on life as we know it, said Shepard. He explained that dust launched into the air would have a major cooling effect, provoking an extinction event like hasn't been seen on Earth in millions of years. His team results were published in the scientific journal The Astronomical Journal. The two other asteroids pose nearest to Earth, but one is the closest asteroid to the Sun ever found. Some 30,000 asteroids of all sizes, including more than 850 larger than a kilometer wide, have been catalogued in the vicinity of the Earth, earning them the label near Earth objects. News, none of them threatened Earth from the next 100 years. According to Shepard, there are likely 20 to 50 larger news left to find, but most are on orbits that put them in the sun glare. In preparation for further discovery of a more threatening object, NASA conducted a test mission in late September in which it collided a spacecraft with an asteroid, proving that it was possible to change its trajectory. Okay, man, great, man. Moving on towards next topic. I'm moving very really fast because we have to cover lots of articles today, and so yep, please cooperate. Antibiotic resistance linked to these household products. The study by Assistant Professor Hume Pang Research Group in the Department of Chemistry in the Faculty of Arts and Science was able to show that triclosan, a chemical often included in household items like hand soaps, toothpaste, and cleaning products to fight off bacteria, is the predominant antibiotic in Ontario sewage sludge. The findings were published in the journal Environmental Science and Technology. Since there are so many different antibiotics in the sewage sludge, we were surprised to find that the majority of the antibacterial activity of the sludge could be directly linked to triclosan alone, says Holly Barrett, a PhD candidate in the Pang group and lead author on the study. The research was performed by investigating sewage sludge from Ontario sewage treatment plants (STPs). As the study notes, STPs are a breeding ground for antibiotic resistant bacteria due to the diverse set of antibiotics that are found there. That's because after we rinse our household products down the drain, the antibiotic ingredients in those products are transported to STPs where they accumulate. Among thousands of co-occurring chemicals in the sludge, triclosan was found to be the predominant antibacterial compound impacting E. coli. Barrett notes in the study that antibiotic resistance is a growing concern. Antibiotic resistant bacteria, also commonly known as superbugs, are strains of bacteria that are not killed by antibiotics. They are produced when continuous exposure to antibiotics causes bacteria to evolve over several generations to survive antibiotic effects. These bacteria can be very dangerous to humans, especially those with impaired immune systems. Between 2014 and 2016, there were 700,000 deaths around the world attributed to antibiotic resistance. In 2016, the US Food and Drug Administration banned triclosan from being used in antibacterial liquid soaps, and then a year later from being used in topical antiseptic found in the healthcare settings. Currently, there are limited regulation on triclosan in Canada, and the Health Canada deems triclosan as safe for use in a variety of consumer products at specified levels. I think our results demonstrate that there is an urgent need of regulatory agencies in Canada to re-evaluate the use of triclosan, says Barrett. It's still used in thousands of different household and cosmetic products in Canada as well as in healthcare settings. While there are a few regulations in place to restrict the maximum amount of triclosan allowed in consumer products, even very low levels of the chemical may cause antibiotic resistant bacteria to form over time. So these are the study, these are the findings given by a researcher on the antibiotic resistant linked to our body, and of course is being used in biomedical appliances and applications. So yep, man, great. Moving on to the next topic, it's going to be and genomes topic, genes topic. So let's see that how our ancient genomes reveal hidden history of human adaptation. Of course, man, we need to identify it. The use of ancient DNA, including the use of ancient DNA, including sample of human, remains around 45,000 years old, has shed light on a previously unknown aspect of human evolution. Dr. Yasina Solvendi, group leader at the University of Adelaide Australian Centre for Ancient DNA, co-lead the new study. The new study published in the Nature, Ecology and Evolution. It was widely believed in the genetic of our human ancestor didn't change due to environmental pressures as much as other animals due to our enhanced communication skills and ability to make and use tools, Dr. Suleimani said. However, by comparing modern genome with ancient DNA, we discover more than 50 cases of an initially real beneficial genetic variant becoming prevalent across all members of ancient human groups. In contrast to many other species, evidence for this type of adaptive genetic change has been inconsistent in humans. This discovery consequently challenges the prevailing view of human adaptation, given us new, exciting insight into how humans have adapted to the novel environmental pressures they encountered as we spread across the planet. Co-lead author Dr. Ray Tobler and adjunct, adjunct, adjacent fellow at the University of Adelaide and a Decada fellow at the Australian National University said examining ancient DNA has been critical in unlocking the secrets of human evolution. We believe historical mixing events between human groups might have hidden signs of genetic change in modern human genomes, Dr. Trobler said. We examined DNA have more than 1,000 ancient genomes, the oldest, which was around 45,000 years old, to see if certain types of genetic adaptation had been more common in our history than study of modern genomes had suggested. Professor Christian Hubert, a senior author of the research group, is an adjunct fellow at the University of Adelaide and assistant professor at Penn State University. The use of ancient genome was crucial because they preceded major historical mixing events that have radically reshaped modern European genetic ancestry, Professor Hubert said. This allowed the recovery of historical signs of adaptation that are invincible to standard analysis of modern genomes. Established in 2005, the Australian Centre for Ancient DNA is the world leader in the research and development of advanced ancient DNA approaches for evolutionary, environmental, and conservation applications. Researchers based at the Mayo Clinic and the Graven Institute of Medical Research and the Max Planck Institute of the Science of Human History in Germany, the University of New South Wales, and Massey University in New Zealand also contributed to the research paper. So, it's great to find our ancient DNA and that how it's being advanced in our modern Homo sapiens. So, I mean, it's going to be have very interesting findings in the historical purposes and many other things which being covered in those things. So, great, man. Okay, moving on towards next topic. Unraveling electron transfer dynamics in photosystem second under water deficit and heat stress in pearl millet. Okay, heat and water deficit stresses tend to impede and restrict the efficiency of photosynthesis, chlorophyll fluorescence, and maximum photochemical quantum yield in plants based on their characteristic ability to interfere with the electron transfer system in photosystem second. Dissection of the electron transfer pathway in photosystem second PS second under water deficit and the heat stress can shed light on the various attributes of the photosynthetic performance of a plant. We hypothesize we hypothesize that Enduring stress specific strategy that can confer adaptive advantages can be employed by plants in terms of changes in photosystem circuit dynamics, and this can help the plants acquire new homeostasis, which can be a productive adaptation. A study on the abiotic stress mechanism in pearl millet has identified details of how electron transport in the PS2 of the pearl millet plant is affected by water stress and heat stress in isolation and combination. Stress due to water deficit and heat stress are closely related in the nature of their incidence and also in the way they affect plants. The stress in combination is a typical manifestation of the changing climate in the tropics. Drought in the tropics can last for several weeks, and heat can be experienced by the crops as waves or hot spells, and is more than accompanied by water deficit. We conducted an experiment by simulating water stress and heat at environmentally relevant proportions to mimic a changing climate scenario at a key crop growth phase. We dissected the electron transport pathway and quantified it in a photosystem second with a chlorophyll fluorescence meter at a saturating light intensity of 3000 mmol meter square with measurement at a high time resolution of 10 ms. The oxygen evolution complex OEC is a part of the system second that split water and is instrumental in the release of oxygen in the atmosphere through the photosynthetic process. The oxygen evolution complex changes were quantified in our study, and we found that OEC damage is the primary effect of heat stress and is not seen with the same intensity in water stress plants. Low exciton absorption flux in heat stress and combined state was seen due to OEC damage, and this caused an electron transport traffic jam in the donor side of PS second. Our result indicate that the functional state of PS second is sensitive to stress, and the differential sensitivity was demonstrated in our study where heat and combined heat and water deficit affect PS second electron transport more severely than water deficit stress in isolation. We developed flux model and found that both the specific energy flux model and the phenomenological flux model developed from the derived values in our study showed that water deficit stress in combination with heat stress has a major stronger effect that the stresses in isolation on the overall electron transport pathway of the PS second in pearl millet plants. Conclusion: we have proposed that pearl millet, which is an inherently drought and heat tolerant crop, can serve as a model crop for climate change studies in the tropic. Abiotic stress in general and heat and water stress in particular affect PS second functioning in plants. They alter the electron transport pathway, which can be seen as a response to stressful stimuli, or it can be result of an adaptive mechanism to overcome the stressful stimuli. Our high resolution dissection of the electron transport pathway in PS second was uncovered how these responses work. We found that a combination of stress can elicit a different response as compared to stresses in isolation. Our attempt was to answer these questions with a detailed study of chlorophyll fluorescence, kinetics, and non photochemical quenching (NPQ) under the stress in pearl millet, pensum glaucum in isolation and combination. A study now published in the Frontier in Plant Sciences reveals the mechanism by which these stresses alter PS second functioning, specifically the electron transport pathway. The result can further our understanding of combined water deficit and heat stress response. It can pave the way of trade discovery and a further selection of useful drought tolerance traits to evolve climate ready cultivars. The study is a part of Science as Dialogue, where researchers can report findings from their published research articles. Visit this page for info. You can visit visit the page of the Science X Dialogue. And how to participate in these kinds of events. So It's being provided in the link itself, so you can check it out. Otherwise, leave it, of course. Moving on towards next topic, researchers explored interfacial shield or for a more frictionless future. Okay, let's see. A professor of chemical and biomolecular engineering, Eliseo Rado, and her team has discovered a fundamental friction law that is leading to a deeper understanding of energy dissipation in friction and the design of two-dimensional material capable of minimizing energy loss. Friction is an everyday phenomenon. It allows drivers to stop the cars by braking and dancer to execute complicated moves on various floor surfaces. It can, however, also be an unwanted effect that draws the water of large amount of energy in industrial processes, the transportation sector, and elsewhere. Try biologists, those who study the science of interacting surface in relative motion, have estimated that one counter of global energy losses are due to friction and wear. While friction is extremely widespread and relevant in technology, and the fundamental laws of friction are still obscured, and only recently have scientists been able to use advances in nanotechnology to understand, for example, microscopic origin of Da Vinci law, which holds that frictional forces are proportional to the applied load. Now, Rido and her New York University tendon postdoctoral research Martin Rajon have found a new method to measure the interfacial shear stress shared between two atomic layers, and they discovered that this quantity is inversely related to friction following a new law. This work, conducted in collaboration with New York University tendon graduate student Francesco Levini and colleagues from the International School for Advanced Studies and the International Center for Theoretical Physics in Trieste, Italy, as well as Prague Charles University, could lead to more efficient manufacturing processes, greener vehicles, and a generally more sustainable world. The interaction between a single atomic layer of a material and its substrate governs its electronic, mechanical, and chemical properties, Raido explains. So, gaining insight into the topic is important on both fundamental and technological levels in finding ways to reduce the energy caused by friction. The researchers studied bulk graphite and epitaxial graphene films grown with different stacking orders and twisting, measuring the hard to access interfacial transfer shear modulus of an atomic layer on a substrate. They discovered that the modular measure of the material ability to resist shear deformation and remain rigid is largely controlled by the stacking order and the atomic layer substrate interaction, and demonstrated its importance in controlling and predicting sliding friction in supported two-dimensional materials. That experiment showed a general reciprocal relationship between friction force per unit contract area and interfacial shear modulus for all the graphite structures they investigated. The paper was published in Nature Nanotechnology. A study can be generalized to the other 2D material as well. Rido, who heads New York University Tendon Pico Force Lab, asserts this prevents a way to control atomic sliding friction and other interfacial phenomena, and has potential application in miniaturized moving devices and the transportation industry and other realms. Elisa's work is a great example of a New York Tendon's commitment to a more sustainable future. Dean Jelena Kovanskwik says, and a testament to the research being done at our newly launched Sustainable Energy Engineering Initiative, which focuses on tackling climate change and our environmental contamination through a four pronged approach we are calling AMDA D for avoidance, mitigation, and remediation and adaptation. It's going to be the last topic of this podcast, so let's see. Exploding pressure gated band edge states of 2D halide perovskites. Okay. In semiconductor heterostructures, reconfiguring the band edge states and modulating their interplay with charge carriers in a continuous manner have been long-standing challenges. Recently, an international research team led by Dr. Zewski Liu from the Center for High Pressure Science and Technology Advanced Research HP Star and Professor Leighton Dew from Purdue University choose the organic semiconductor, incorporated 2D halide perovskites as a model system, and discovered that lattice compression induces band element switching and charge redistribution, which relies controllable emission properties of these 2D hybrid semiconductor heterostructures. The work has been published in the latest issue of Science Advances. Two-dimensional 2D semiconductor heterostructures are key building blocks for many electronic and optoelectronic devices. Fundamental questions remain regarding the effect of the interfacial band states on the carrier dynamics and optoelectronic properties, which is limited by the scarcity of suitable material system, as well as the difficulty in continuously tuning the frontier electronic structure via conventional methods. Dr. Liu, to this end, we propose that relies the manipulation of band edge states and charge distribution via mechanical rather than chemical or thermal regulation. By continuously regulating the energy level of organic and inorganic building block of organic semiconductor, incorporated 2D halide perovskites using external pressure, the researchers have demonstrated the possibility to fine-tune the band edge states and the charge distribution of the 2D semiconductor heterostructure, which was previously unattainable. The band element transition at the organic inorganic interface is intrinsically not well resolved at room temperature, owing to the thermally activated transparent shuffling of band edge carriers, explained Sungyo Gyo, a PhD student at HP Star. Thus, we introduce a two-level thermal equilibrium model to describe the chain distribution in the perovskite layers and organic ligands, and the energy level difference can be accurately determined by fitting the C2 temperature-dependent PL spectra. The researchers have also proposed a pressure gating strategy that enables the control of multiple emission states within a single material. For the 2D halide perovskite and VDW semiconductor exhibiting different pressure response of the building units, pressure processing not only provides an effective and clean manner to modulate their lattices, but also offered new opportunity for achieving configurable electronic properties with designable band edge states and band elements. It is believed that the principle presented in this work could serve as a blueprint for the design, production, and fine tuning of many other functional semiconductor heterostructures toward the realization of high performance by manipulating the band edge states and the interfacial charge distribution. Moving on towards next topic. Physicists shed new light on unanswered questions about glass liquid transition. Glasses are peculiar material exhibiting excellent well-known properties, but also some phenomena that are still not fully understood, even though they have been studied for more than a century. In particular, researchers have not yet reached a complete description of the glass formation process upon cooling a liquid and the converse transition of glass to a more stable state called supercooled liquid when it is heated up. A study recently published in Nature Physics, led by members of the Department of Physics and the Universitat Autónoma de Barcelona, UAB, and the ICN2 thermal properties of nanoscale material group, sheds new light on this conundrum. Glass is an amorphous solid, a state of matter characterized by the absence of a long-range order. In other words, it has not a, it has not a crystalline structure as a regular solid, but its molecules cannot move as in a liquid either due to a very high uh, viscosity. Since the state is not energetically stable, atoms or molecules in glasses tend to rearrange themselves over time, leading toward a more stable configuration, such as configuring process which occurs naturally is facilitated by an increase of temperature when a glass is heated up to specific transition temperature. Its component acquired additional mobility and the material becomes a supercooled liquid. Conventional, Conventionally, this transition from glass to liquid is described as a dynamic process in which atoms of molecules go through a cooperative relaxation. This means that region of the glass having slightly higher mobility induce adjacent zone to progressively transit to a liquid state and reach an equilibrium phase. According to this theory, the increase of mobility is gradual and the relaxation takes place in the whole material in a cooperative and almost uniform fashion. But is it always so? Okay. The above mentioned study, led by Professor Javier Rodri- Rodriguez Viejo and Dr. Marta Gonzalez Slaveria, group leader and senior research respectively in the ICN2 thermal properties of nanoscale materials group and the Department of Physics at the University of Autónomo de Barcelona, UAB, provides a more precise description of this phenomenon. The researchers demonstrated experimental that under specific conditions, the transition from glass to supercooled liquid can originate from a rapid formation of localized liquid regions whose mobility is much higher than that of the rest of the material and which expand quickly. This results in a stage where parts of the material are already in a stable liquid phase while others are still glassy, something that doesn't occur with cooperative relaxation. For these two states to coexist in localized region, the difference in mobility between the liquid and the glass parts must be very significant. The author demonstrated that both these mechanisms, that is, the formation of expanding liquid region and the cooperative relaxation, can take place when the glass is heated up, depending on the condition of the processes. Which of these to prevail is dictated by the specific temperature of the glass, but doesn't depend on this procedure used to form the original glass or on its initial stability. The study whose co-authored are Anna Bila Costa, Dr. Christian Rodriguez uh, Tinoco, and Marta Rodriguez Lopez was made possible by the use of advanced laboratory techniques such as nanocalorimetry, which allows observing glass dynamics at the nanoscale and performing measurements at temperature ranges and time scale that cannot be achieved by by conventional methods. These results add new important pieces to the description of a complex glass liquid transition process open the way to new theories and in-depth studies. A deeper understanding of the physics of glass will enable its properties to be exploited for new or improved applications. In particular, this exotic transformation mechanism is behind the very high stability of vapor deposited ultra stable glasses, including the organic ones, and may therefore have a positive impact on the dur- durability of organic devices or the production of the metallic glasses with enhanced mechanical properties for wear and corrosion resistant coatings. So these are the studies, these are the findings uh, based on which our physicists gave answers to this glass liquid transition. So this is the end of this podcast. And yes, at last I just want to say you guys keep researching, stay curious, stay healthy.